All right, so the point slope form of the equation is y minus y1 is equal to m times x minus x1. Okay, where m is the slope, as usual, and then x1, y1 is a point on the line. So these are actual numbers. And then x and y are just x and y. So they stay letters.
So we're not gonna write up here. We did it yesterday.
Mm-hmm.
So I can like write some of this up there.
Yeah, absolutely. Hold on.
I mean, I'm gonna put an arrow just so I can have space.
Okay, so what we're going to do then is we're going to write an equation in point slope form. That goes through the point 3, -2, and the slope is 1/4. And then we're going to graph it. Okay. Well, the point slope form again is y minus y1 is equal to m times x minus x1. Our x and x1.
Oh.
There's a little sub here. So y and x just stay y and x. But this point right here is x1, y1. Okay, so I'm going to do y minus y1, which is -2, is equal to m, which is 1/4, times x minus x1, which is 3. So we're going to plug in.
We're going to have to figure out the slope and then figure out point slope.
Okay, then the second thing we want to do is simplify. So he's happy, so he's going to be positive. And then I'm going to distribute this 1/4. I'm recording. Okay, so that's going to be y plus 2 is equal to 1/4 x minus 3/4. Okay, now this is not my y-intercept. See, I have this 2 over here. So this is not slope-intercept form. This is point-slope form. To graph it, I'm going to come and I'm going to go back to my original point, x1, y1, and I'm going to graph that point. So I have 3, -2. I'm graphing this point right here, the original point.
You always start at 0, 0, 0.
No, the coordinate for this point is I go to 3 on the x-axis and then 2 on the -2 on the y-axis. So that brings me right
completely confused, messed up, like your class and Miss Sexton's class. I thought it was supposed to be.
Okay, so.
And then you go up from there.
Yeah, so
right?
instead of, normally we graph the y-intercept and then we count from there, but this time we don't know the y-intercept because we're not in slope-intercept form. So we start at our original point, which is here, and then we count our slope from there, so we're gonna go up 1, over 4 from there. And then we're gonna graph our line.
Your graph is really much bigger than ours, right? Mine's a little bigger.
This way. All right, so I've got the vertices are these points, and I've got the sides. So I have the side UT, I have the side ST, the side RS, and the side RU. We're going to write the equations in point slope form. So I need the slopes. So to find the slope, I can just count from U to T. So from U to T, I go up 1, 2, 3, and then over 1, 2, 3. So if I go up 3 and then over 3, that's just 1, right? You guys agree? If I do ST, I'll go down 1, 2, 3, and then over 1, 2, 3. So I went down 3 and then over 3, so that's -1. RS, up 3, over 3. So that's 1. And then RU, down 3, over 3. So that's -1. So those are my slopes, 1s and -1s. Questions so far?
So these are all your M's, all the ones and negatives?
Yeah, these are my M's. Okay, now, a point on the line is any point on the line. So if I'm saying the line UT, I could use the point U or I could use the point T because they're both on the line, right? So what do you guys like, 4-2 or 7-5? All right, we'll go with 7-5. So the equation for UT is going to be y minus y is equal to m, UT is a 1, times x minus x, so that's a 7. So that's going to be y minus 5 is equal to x minus 7.
What is the last one on sides say?
Here?
Yeah.
Okay, are you?
Are you?
Yeah.
This
Sorry, my U's kind of
is.
loopy.
And that's the answer?
That's the answer. Because it just asked me to write an equation for the line, and that is an equation for the line. So we're done for that one. Now we'll go to the next one, which is ST. And because both points S and T are on the line ST, I can use either point, right? Do you want to use T or S?
Yes.
Okay, we'll use S on this one. So I'm going to do y minus y1, so that's 8.
I think it's possible to estimate the answers.
And then ST is a negative slope, so I've got -1 times x minus 4. So it gets me y minus 8 is equal to -x plus 4. Gonna switch to blue. Okay, then I have the side RS. you want to use R or S?
Like 5 R.
Okay, we'll use R. So I have 1, y minus 5 is equal to, our slope for RS is 1, times x minus 1. So I get y minus 5 is equal to x minus 1.
Gibberish.
And then finally, RU. My slope is -1. And the only point we haven't used yet is u, so we might as well use u. So we'll do y minus 2 is equal to -1 times x minus 4. Distribute that -1. So y minus 2 is equal to -x plus 4.
No.
Okay, so standard form is ax plus by equals c. Okay, and there are some rules about standard form. Okay. A is positive or greater than 0. And then A, B, and C are all integers. Okay, that means no fractions, no decimals. They have to be whole numbers, and A has to be positive. B and C don't have to be positive, but A does. So if we have a equation,
Did we learn this already? Because this was on the midterm. I don't know this.
okay, so we have the equation, we're going to turn this into standard form. You guys hate fractions?
Yep.
Let's get rid of the fraction. What am I going to multiply by to get rid of this fraction?
3.
3. I'm going to multiply everything by 3. So 3 times y, 3 times 1, 3 times -2/3 times x minus 5. Now I don't have to put another 3 here because these are already being multiplied. So when you multiply two things together and you multiply it by 3, it's all being multiplied together. So be careful with that. Don't put an extra 3. Okay. 3 times y is 3y. -3. 3 goes into 3 one time. And then 1 times -2 is -2 times x minus 5. And then I need to distribute this -2. So I'm going to get 3y minus 3 is equal to -2x plus 10. And now I need to take this and make it look like this. So I'm going to take this 2x and I'm going to move it over here and I'm going to change the sign. That does not look like a G,
Looks like a swish.
doesn't it? It says sign right there. Okay, so I'm going to change the sign. So that's going to give me 2x plus 3y minus 3 equals 10. Which I'm going to rewrite over here. Just, okay. Then I'm going to add 3 to both sides. I'm going to get 2x plus 3y equals 13. No fractions, no decimals, and A is positive. If this ended up being a -2, all I would do at that point is change every sign. Does that make sense? Because this has to be positive to be standard. So We want to get rid of the fraction? So we're going to get rid of the fraction, so we're going to multiply everything by 2. So I'm going to have 2 times y plus 2 times 3 plus 2 times, not plus.
So it's pretty much just simplifying and then moving one of them to make it the right order.
Uh-huh. Exactly. Okay, so I'm going to multiply everything by 2 to get rid of that fraction. So I get 2y plus 6 is equal to, well, 2 goes into 2 once. 1 times 3 is 3. So 3 times x plus 1. Distribute the 3. So I get 2y plus 6 is equal to 3x plus 3. Well, I want this to look like y equals mx plus b. So I'm going to subtract 6 from both sides to get the y alone. So that gives me 2y is equal to 3x minus 3. But I don't want 2y, I just want y. So I have to divide by 2. And I have to divide everything by 2. And that gives me y is equal to 3 halves x minus 3 halves.
And that's B.
Okay, if you never ever want to write the word perpendicular again, you don't have to.
Parallel.
Here is the symbol for the word perpendicular.
It's what?
No, that's the upside down T. And here's the symbol for the word parallel. So you've got 2 parallel lines. You don't have to put the parentheses. So I'm just putting in parentheses. So if I want to say, you know, if I wanted to write perpendicular lines, now I can just go perpendicular lines or parallel lines. Okay? So there's that. So let's talk about parallel lines. Parallel lines never intersect. In order for this to happen, they have identical slopes. And you guys have a lovely picture of 2 parallel lines. Okay. Technically, parallel lines are also non-vertical.
What happens if they're vertical?
Because vertical lines have an undefined slope, so technically speaking, a whole bunch of vertical lines aren't really parallel to each other because they don't have identical slopes because they have no slopes.
So these lines aren't parallel?
Technically speaking, no. There's something else. But they are parallel, really.
What about the ones that go to the side?
Those are okay because they're all zeros.
Like straight to the side?
But those aren't?
No, no.
If they go straight up and
Vertical lines technically are not parallel because their slope is undefined. And the definition of parallel is to have identical slopes.
But the symbol for parallel lines are vertical.
I know. I can come up with this. Okay, so if you are writing equations to parallel lines, we're going to use the fact that their slopes are identical. Okay. We want to write the line that goes through this point, but that's parallel to this line. Okay, so basically what we're looking at is we have some line like this, right? And that's this line. And then there's a point, and I don't know if it's actually on that side or this side, but there's a point, 3, 5. And we want to make a line through it so that it's parallel. Make sense? Okay. So,
Wait. But why?
because we can.
Very.
Okay, why? So, we have a point and we have a slope. So if M is 2, well, parallel M is also 2, right? Because parallels have identical slope. And then we have x and y. We have our formula. We plug in our y. We plug in our m. We plug in our x. And we find b. So add 6 to both sides. B is 11. So the equation of the parallel line is 2x plus 11. That would be that parallel line right there. Lines, if parallel lines have identical slopes, okay, perpendicular lines have slopes that are opposite reciprocals.
What?
Okay, so if, say we have a slope that's 3, that slope would be perpendicular to -1/3. So we have to flip it over and negate it or take the opposite of it. If I have a slope that's already negative, the perpendicular slope of that is going to be positive and flipped over. Okay, so perpendicular slopes are negative or opposite reciprocals. So flip it and change the sign. Yes, and this is the technical mathematical term. Flip it and change the sign. Not really. Okay, so to find out if these two lines are perpendicular, we need to find the slope of each line. And if we recall the slope formula, okay. The slope formula is y2 minus y1 over x2 minus x1. So I'm going to start here with the first line, and I'm going to find its slope. So I'm going to call it line 1, m1. And I'm going to do 1 minus 3 over 7 minus 2, which is going to give me -2 over 5. Okay, and then the second one, I'm going to have 6 minus 1 over 4 minus 2, which gives me 5 over 2. I am flipped. I am opposite. So yes, I am perpendicular.
I don't know what just happened.
To determine what slope I need for a perpendicular line, I first have to figure out what slope I have. So first I need to put this into y equals mx plus b format. So we're going to turn this into y equals mx plus b. So in order to do that, I'm going to take this 3x or 2x and I'm going to put it over here and change the sign. Which is going to give me 3y equals -2x plus 12. But I still need to get rid of that 3. So I'm going to divide by 3. And that's going to be y equals -2/3 x plus 4. So m is -2/3. If I don't want m, I want to know what slope is perpendicular to that. So I'm going to flip it and change the sign. So perpendicular is gonna be 3/2. This is the slope I'm gonna use because I want to make a perpendicular line. So I've got my x and my y and my m. Gotta find my b. So I plug in my x, or sorry, my y, my m. Well, 2 goes into -4 2 times. And then 3 times -2 is -6. I'm going to add 6 to both sides. And b is 12. Yeah, 12 does equal 12. B is 12. So then my equation is going to be y equals 3/2 x plus